In this problem, I'm given a graph, and I have to define what the piecewise function is. I have to write the piecewise function algebraically. So remember, with the piecewise function, I'm going to have f of x is equal to more than one piece. And in this case, I can see pretty clearly I have two pieces. I have this piece over here, and I have this piece over here. So piecewise functions on the top, they start the farthest left. So I'm going to start with this piece, which is the farthest left. And this piece here will be my bottom piece. The other piece is more to the right. That'll be the bottom piece. So I can see that my first piece over here is a horizontal line. So horizontal lines are constant functions, and I can see that it goes right here to -1. So the function right here is y equals -1. But it's not just y equals -1. It starts where x equals 4. So this is y equals -1, but only for x less than or equal to -4. So I know that it's less than or equal to because -4 is right here and it's a solid dot. And for all the x's less than or equal to -4, my y value is equal to -1. That one's pretty straightforward. The next one, though, well, it's a line, so I know it's going to take the form of y equals mx plus b. And if you remember properly, m is the slope, and b is the y-intercept. So let's see if we can figure out the slope of this line right here. Well, it looks to me like I'm going, well, I'm going to go, I mean, it's hard to see because this is in twos, but I go down 1 over 1, down 1 over 1. Or you can look at it as down 2 over 2. Or you can start it here and go down 2 over 2. So my slope on this is -1. So my slope is -1. So -1x. And my y-intercept, where am I intercepting the y-axis? Well, it looks like I intercept it right here at -1. So my b is equal to -1. So my equation is y equals -1x minus 1, or more simply wrote, equals -x minus 1. So my second piece is -x minus 1, but only for x's that start at -4 and go positive, because all these are positive x's here. So I want all the x's, I want x greater than -4, not greater than or equal to, because it was an open circle. So that's how I would define this function algebraically. If I'm looking at the domain of this function, which is not a bad thing to look at, domain is all valid x values. I'm going all the way this way to -infinity, and I'm starting here, and I'm going all the way to +infinity for my x values. I mean, you can see it on the slope of the line. It would keep on going, and all my x values would keep increasing.
You don't have to do that.
So the domain of this function is -infinity all the way to +infinity. Let's take a look at the range. Range is a little bit tricky, especially in a problem like this, because as English readers, we read from left to right. But in this particular function here, I can see that my y values, which is range, they're going to keep going all the way down to -infinity. So my range is going to start at -infinity, and it's going to keep going up in this direction here, all the way until it hits Well, that looks like positive 3. But positive 3 is not included, it's an open circle. Now, it includes the y value here at negative 1. I don't really have to do anything special because of this one here, because it is included in the range right over there. So this is the range of this function.